First off, what's the square root of 9? And click over here to review. Right, the square root of 9 is 3 because 3 times 3 equals 9. Now let's switch things up a little bit. Suppose you have the equation x squared equals 9. There are actually two solutions to this equation. You already found one of them. X could equal 3 because 3 squared equals 9. But there's actually another solution to this equation. What other value for x satisfies this equation? What other number can you square to get 9? Exactly, x can also equal -3. So both 3 and -3 are solutions to this equation. But when we say the square root of a number, we're referring to the positive root. Let's try another example. The equation x squared minus 16 equals 0. This is an example of what's called a quadratic equation. That's an equation where you have a quadratic polynomial on one side and 0 on the other. So, can you figure out a solution to this quadratic equation? Exactly, x equals 4 is one solution to this equation. And what's the other solution to this quadratic equation? Right, so x can also equal -4. So both 4 and -4 are solutions to this equation. A concise way to write that is like this. This symbol here is the plus or minus symbol. So this equation means that x can be equal to +4 or -4, and it's the solution to this equation up here. Now what if we had a 13 in this equation? Now what are the solutions? Nicely done. So x can equal the square root of 13 or negative the square root of 13. Next, let's try a more complicated equation. X minus 2 squared minus 25 equals 0. What are the two solutions for this equation? Excellent work! So x can equal 7 or -3. Sure enough, if you try plugging both of these numbers back into the original equation, they both work. 7 minus 2 is 5, and 5 squared equals 25, so the left side equals 0. And -3 minus 2 is -5, and squaring that also gives you 25. Okay, try one last example. 2 times x plus 4 squared minus 18 equals 0. What are the solutions to this equation? Nicely done. This time you added 18, then divided by 2, and then solved for x. The two solutions are -1 and -7. Many quadratic equations have two solutions like this. Now how would you solve a quadratic equation like this one? 2x squared minus 4x plus 7 equals 0. Well, you'll discover a formula for quickly solving any quadratic equation in a later lesson. To get started, can you identify which of these polynomials are quadratic? And click down here if you'd like to review. Right, so these two polynomials are quadratic because they have degree 2. This polynomial has degree 1, so it's called a linear polynomial. And this polynomial has degree 3, so it's cubic. Let's quickly take a closer look at x minus 1. If we have the equation y equals x minus 1, then which of these lines is the correct graph? And click down here if you'd like to review graphing lines. Right, so here's the graph for y equals x minus 1. Every point on this graph, like 2, 1 over here, satisfies this equation. When x equals 2, y equals 1. In this lesson, we'll be coming up with a graph for the equation y equals x squared. Now, when x equals 2, what does y equal? So for the equation y equals x squared, when x equals 2, y equals 4. So then 2, 4 should be one of the points on our graph. Go ahead and plot this point. Great, so 2, 4 is over here. Next, plot the point whose x-coordinate is 1. So first use this equation to determine the y-coordinate and then plot the point. Exactly, so 1, 1 is also part of the graph for this equation. Next, plot the solution whose x-coordinate is 0. Right, 0, 0, the origin, is also part of the graph. Now let's try some negative x-coordinates. Plot the point whose x-coordinate is -1. Right, Negative 1 squared is positive 1, so you added negative 1 comma 1. And now plot the point with an x-coordinate of negative 2. Right, so here's negative 2 comma 4. Now so far we've only been plotting points with integer coordinates. So which point has an x-coordinate of 1.5? Again, find the y-coordinate and then plot the point. If you're off by a little bit, don't worry. Just try to be close. Nicely done. 1.5 squared is 2.25, and here's the point 1.5 comma 2.25. Alright, last one. Plot the point whose x-coordinate is negative 1.5. Okay, so here are the points you found so far on the graph for y equals x squared. And if you were to plot all the points on the graph, you'd get this curve. This specific curve is known as a parabola, and you'll see a few more parabolas in this lesson. So if this is the graph for y equals x squared, can you identify the graph for y equals negative x squared? So remember the order of operations. This means take x, square it, and then make it negative. Here are a few more parabolas. Which is the graph for y equals negative x squared? If you get stuck, try plotting a few solutions to this equation. Nicely done. So this is the graph for y equals negative x squared. One way to see this is that for every point on the graph for y equals x squared, you're now multiplying by negative 1 when you calculate the y-coordinates. So all the y-coordinates are now down here below the x-axis. Next, try identifying the graph for the equation y equals x squared minus 2. Again, if you get stuck, try plotting a few solutions to this equation. Exactly, so here's y equals x squared minus 2. This time, when you're calculating the y-coordinates, you're subtracting 2 at the end. So you'll notice that all these green points have y-coordinates that are exactly 2 below the purple points of the original parabola. Next, let's quickly take a closer look at this graph. What's the y-intercept for this graph? Right, you can look at the graph and see that it crosses the y-axis at negative 2. And a general way to find the y-intercept is setting x equal to 0, because for a point to lie on the y-axis, its x-coordinate must equal 0. So if we set x equal to 0 in this equation, 0 squared is still 0, and we see that, sure enough, y equals negative 2. So the y-intercept for this graph is negative 2. Now to find an x-intercept, you would set y equal to 0. So we have the quadratic equation 0 equals x squared minus 2. This equation has two solutions, and that matches what you see in the graph. There are two x-intercepts here. Try solving this equation for one of its solutions. What's one of the x-intercepts for this graph? Precisely. So this parabola has two x-intercepts, one at the square root of 2 and the other at the negative square root of 2. So by solving quadratic equations like this, you can find the x-intercepts for quadratic polynomials. And in a later lesson, we'll take a closer look at finding the x-intercepts of parabolas.